All right, everyone. I'm doing this video to show you a couple of different things today, but we're answering the question, is 4 comma minus 2 a solution for this equation, 3x minus 2y is less than 12, which is represented here graphically. So what I want to do is cover a couple of things in this one video. The main thing is going to be looking at a graph and then determining whether a point is or is not a solution. But before we do that, I wanted to point out that the graph itself has some important features. For example, we have a dashed line. So I'm going to kind of like sketch over here, dashed line, okay? Kind of like, you would read a legend. Well, dashed lines are always representing a situation where the inequality will be a less than inequality or a greater than inequality. Okay, so whenever you see a dashed line, it's it's always going to have an inequality that's of the form less than or greater than. However, if you have a solid line, then that's always going to be either a less than or equal or a greater than or equal. You'll always have an equal component with this solid line. Now, you're probably saying, okay, I kind of get that, but what does that mean to me practically? Well, here's what it means. Here we have this graph, and we've got a dotted line, and we see this shaded area above the line. Okay, so that's pretty clear. The shaded region is the solution region. So, because we have a dashed line, the solution region is just the part that's above this line. It doesn't include any point that would be on this line. So, for example, the y-intercept here would be 0 comma minus 6, right there. I'm going to just kind of like pencil in an intercept. Well, that point on the line is not actually part of the solution because it's a dashed line. I will prove it to you in a few minutes. Okay, so that's what you got to know about dashed lines is the line itself is not part of the solution space. Okay, but now going back to this, is 4 comma minus 2 a solution for 3x minus 2y is less than 12? Well, there's multiple ways to do that. You can evaluate it, but I wanted to show you just graphically because you will get these types of questions on EOC tests and SAT tests and ACT tests and things like that. So you need to know this. So here's what I'm going to do. I'm going to go find this point on the graph and I'm just going to mark it. So 4 comma minus 2. So starting at my origin, I move 1, 2, 3, 4 in the X and then 2 down in the Y, and it's right there at this intersection. So that's the point 4 comma minus 2. Brilliant. Okay, now, is it in the solution region or is it outside of the solution region? Well, it's not in the shaded area, so it's outside of the solution region. So we can right away say the answer to the question is no. It's not a solution for this particular inequality. Now, let's go ahead and prove it by evaluating. So I'm going to go put my point in 3 times x. Okay, x is 4, correct? All right, and then minus 2y, so that's 2 times, well, y is minus 2, okay, and all of that is less than 12 according to the inequality. So I've got 12, and then minus 2 times minus 2 is plus 4, okay, and less than 12. 16 is less than 12. Clearly, 16 is not less than 12, so the answer is nope, that doesn't work. So that corresponds with nope, it's not part of the solution set. because if it was, then you would end up with a situation that makes sense. Okay, now back to the point that I was trying to make about uh, being on the line or not on the line. Let's go ahead and evaluate 0. We're going to evaluate now. I'm going to box this off. I'm going to evaluate 0 comma minus 6, which is a point on that line. Okay, so again, we do the same thing. 3 times x is 3 times 0. Okay, and then minus 2 times y, so minus 2 times minus 6. Okay, and all of that is less than 12. All right, well, 3 times 0 is 0. Minus 2 times minus 6 is plus 12. Okay, less than 12. So is 12 less than 12? No, it's not. It's equal to 12, but that's not what it's asking for. If this said, is 12 less than or equal to 12, then yes. But if it was less than or equal to, it would also have one of these solid lines. So clearly, 12 is not less than 12. So the answer is no. That point is not a solution. And that point happened to be on that line. So thereby just proving to you that dashed lines are always less than or greater than. They're not part of the solution set. All right. So I hope you found that helpful. Now you're going to go and solve some inequality problems. You're looking at the graphs and points and making a determination using your knowledge whether those points are a solution. All right. Good luck, everyone, and see you in the next video.